Right, I keep saying right, it's very annoying. So, Faraday's first law. So Faraday, again, amazing. It's all this electroplating, calculating how much of something we're going to get, or how much energy we have to put in, or how long we're going to have to leave something for if we're given that energy. So this is a bit of algebra is going to come into here and rearranging equations. But first, I think it's really going to be really important, especially if kind of physics isn't your thing, if you have basic thinking about the units you have. So you get given the equation, you get given the constant that you need to use, but you don't get given what these things mean. So you just get QI equals IT. What that means, if you haven't kind of really realized what those things are, it means nothing. So you need to understand these vocab terms and these letters. So I've got them. I will remember, I'll forget some of them, like because the letters don't necessarily match and we talk about one thing and the other. You will be the experts. You will get this, and we will have, maybe I'll put something up somewhere. I'll make a list that's nice. All right, so we have some units. So the first one is a capital C. This is and I have to check my spelling because I can't spell. Column. Anyway, it's our measure of electrical charge. So it's just a measure of that charge in column. Next one is I, which is our current. That's our rate of flow of electrons. So it's how much that flow. It's like a current in a river or a stream or something. It's how much that flow is happening. Then we have Q, which is our amount of electrical charge and our unit C. So we're going to be working out Q, and then your unit's going to be this C column. So Q is Q. It's Q. Oh, that's electrical charge. Yeah, electrical charge is Q. Then F is Faraday's constant. So we'll cover more of that next session. That number, again, it's one of those things, is in your data book. In that little table there, the physical constants bit. So you don't have to worry about remembering that one, you just have to know where it is and what it means and how to use it. And then the final one I think is important. There might be more that come around. We can add to these if you're finding them tricky. Remember, I said keeping the vocabulary stuff is going to be really useful. I found some good resources, but make sure you're keeping on top of it because there's just more and more stuff going to be thrown at you. So amperes or amps, that's our amount of current. So that's amount of flow of our electrons. So that's the kind of key vocab that you need for this, as I see it. So what we have for our first law. So first law, there's two laws. There's not millions to remember, but the first law probably don't need a full stop. So Faraday's first law is that Q equals IT. So what does that mean? So we can break it apart. It means that our amount of electrical charge in columns is equal to the current, so that rate of flow times time in seconds. So however much charge we get has got this relationship to our current and our flow. And what that means is that we can then end up with this kind of graph. So we can see that as we increase our charge of whatever our thing is, whatever, thinking back to our spoon, as we increase the charge that we put in, so the amount of those electrons that are going into our system, the mass is going to increase. So put the charge in pretty low, we're going to get some mass added on my spoon. Apply lots and lots and lots of charge, either over lots of time or a lot of it at one point, we're going to end up with more mass. So it's about that relationship and understanding that if I give it lots of time, my spoon in that, my metal spoon in the silver solution with the silver ions, I'm going to get lots of charge. I've got to get lots of added silver. If I don't leave it very long, I'm not going to get very much. So where is my question? Oh. So the question you might get given at this point, so a current of 1.5 amps was applied to an electrolytic cell for 12 minutes. What total charge was applied? So the way we do this, right, what's it asking and what information? So highlighters are going to be useful. So we've got these two values and what we want to find is that. So we are given this information. So we've got our I, which is this one. We also have our time, but we need time in seconds. So all we have to do is do that. So dt. Oh, I don't have a calculator. I should be good enough at maths to work that out. 12,600. 670. Yep. If my math is wrong from here, then it's because I don't have a calculator and I can't do maths in my head anymore. Right. Then we have this number for here. I can go in here. So Q equals I times T. 1.5 times 720 plus 360. 1,080, and the unit is 6. But remember our significant figures, and I might cover this next term when we have that big chunk that's more than we need to do our prac. Some of these skills. So I have 2 significant figures, that's given me too many. So what I can do is 1.08. Is that right? No, it's not. No. 1.1 times 10 to the you're going to have to be able to rearrange this, but remember our lovely kind of, I call them physicsy triangles, but remember you can just then go. So if they want to tell, if this question is real world, is I know that my charge was this and my current was that, how long did I run it for, or the equivalent, you just have to use this and our understanding. So we want the time, you cover that one, and you've got Q over I. You want the current, you've got the Q over T. So that's our first law.